Ang susunod na programa ay rated G. Ito ay pwede sa lahat ng manonood.
Magandang umaga sa inyong lahat. I'm Teacher Grisha. I'm Teacher Wendy. I'm Teacher Dina.
And I'm Teacher Carlo.
Maging matalino at makamatya para matuto dito lang sa Makiwala. Working with algebra tiles is our topic for today. So listen attentively to learn productively. Let us begin. Algebra tiles are manipulative used to enhance a student understanding of the subject traditionally taught at symbolic level, provide access to symbol manipulation for students with weak number sense, provide geometric interpretation of symbol manipulation. It supports cooperative learning, improve discourse in classroom by giving students objects to think with and talk about. When I listen, I hear. When I see, I remember. But when I do, I understand. Algebra tiles are made up of small squares, large squares, and rectangles. The number 1 is represented by the small square, which is also known as the unit tile. The rectangle represents the variable x, and the large square represents x squared. The length of the side of the large square is equal to the length of the rectangle, also known as the x-file. When visualizing these tiles, it is important to remember that the area of the square is s squared, which is the length of the side square. So if the length of the sides of the large square is x, then it is understandable that the large square represents x squared. The width of the x tile is the same length as the side length of the unit tile. The reason that the algebra tiles are made this way will become clear through understanding their use in factoring and multiplying polynomials. Commercially made algebra tiles are usually made from plastic and have one side of one color and the other side of another color. The difference in the color is supposed to denote one side that is positive and one side that is negative. Traditionally, one side is red to represent the negative and one side is green to represent the positive. Having the two colors on both sides allows for more numbers to be represented with the same type. It also makes it easier to change positive to negative when performing a procedure such as multiplying a positive and a negative number. There are some tiles where the positive x and x squared tile will be same color, but the positive unit tile is different color. This representation is still alright to use. It is just important to have at least two colors to denote positive and negative. Why use algebra tiles? They are inexpensive and widespread. They also make it possible to the activities that are needed to introduce and explain the distributive law and factoring. It also provides a useful way to introduce operations on polynomials. It works extremely well with all ages. How do algebra tiles work? Algebra tiles are manipulative with which you can represent polynomials and perform polynomial operations such as adding, subtracting, multiplying, and dividing. Each tile represents a specific monomial. Algebra tiles work by the concept that every rectangle has a length, width, and area. The lengths and the widths are the lengths of the sides of the rectangle in some unit. We will be working with unit x. The area is how many squares of that unit it takes to cover the rectangle. So these are the three monomials which we will be working with. This is the largest square, which is x squared, the rectangle, which is x, and this is the smallest square, which represents 1 unit. Now let's proceed to the representation of tiles. Let this small yellow square represent the positive 1 unit, while the red small square represents the negative 1 unit. The yellow and the red squares are additive inverses of each other. Let us proceed to zero pair. It is called a zero pair because they are additive inverses of each other. When put together, they cancel each other out to model zero. For example, 1 unit positive tile plus negative 1 unit tile is equals to 0. So this can be called as a zero pair. So this can be called as zero pair. The next example is the x plus negative x is equal to 0, as well to x squared plus negative x squared is equal to 0. So these are called all zero pairs. Addition of integers. Addition can be viewed as combining. Combining involves the forming and removing of all zero pairs. In case number 1, both integers have positive sign. For example, 5 plus 3. We represent 5 plus 3 in algebra tiles as 5 units yellow tiles plus 3 unit yellow tiles since they are both positive. After representing the number of units in the algebra tiles, we are to arrange or combine the algebra tiles now and then count the number of tiles. After representing the number of units into algebra tiles, we are to arrange or combine the algebra tiles now and then count the number of tiles. 1, 2, 3, 4, 5, 6, 7, 8 equals 8 unit tiles. So there are 8 tiles all in all. Now let's proceed to case 2. When one integer has negative sign and the other is positive. Example, negative 6 plus 5. We represent negative 6 as 6 unit negative red tiles and 5 as 5 unit positive yellow tiles. After representing the number of units in the algebra tiles, we are to arrange or combine the algebra tiles and make a zero pair, then count the number of tiles left. So these are the zero pairs. After making the zero pair tile, we are now left with 1 unit negative tile. Case 3, when both integers have negative signs. Example, negative 7 plus negative 4. We represent negative 7 as 7 unit red tiles and negative 4 as 4 unit red tiles, since they are both negatives. By combining all the tiles together, we are able to obtain 11 unit red tiles, which is equal to negative 11. Now, try it by yourself. 3 plus 7, negative 9 plus 9, negative 7 plus 10, negative 12 plus 6, and negative 13 plus negative 15. I know that you can now master the concept on adding integers with different cases, so let us now proceed with our next topic, which is subtraction of integers. Subtraction can be interpreted as takeaway. It can also be thought of as adding the opposite. I will show you how to subtract integers by taking some examples. In the case 1, both integers have positive sign. For example, positive 9 minus positive 4. We represent 9 into algebra tiles as 9 unit tiles and 4 as another 4 yellow tiles, since they are both positive. We will take away 4 positive unit tiles from the 9 unit positive tiles. So we now take away 4 positive tiles. 1, 2, 3, 4. So we are now left with 5 unit positive yellow tiles. Another case is when one integer is negative and the other integer is positive. For example, negative 6 minus positive 4. We represent negative 6 into 6 unit red tiles, while passing 4 as 4 unit positive yellow tiles. Just remember always that red tiles represent 1 unit negative tiles and yellow as 1 unit positive tiles. So it will become as negative 6 unit red tiles and positive 4 unit yellow tiles. We will arrange now the tiles and make a zero pair. So we take away 4 unit yellow tiles from 6 unit red tiles. All in all, there are 4 zero pairs. So we are left with 2 unit red tiles. So we are left with 2 unit red tiles, which is equal to negative 2. On the other hand, first integer has negative sign, and the number of units is lesser than the other integer. For example, negative 2 minus 6. We represent negative 2 as 2 units red tiles, while negative 6 as 6 unit positive yellow tiles. So we will take away 6 units yellow tiles from 2 unit red tiles. But how can we take away 6 unit tiles from these 2 unit red tiles? As what we can see, 6 yellow tiles are greater than the 2 unit red tiles. Well, we can take 6 unit yellow tiles from 2 unit red tiles by the concept of zero pair. It will become, or it will transform as, so we take away all the 6 positive yellow tiles. So we are left with 1, 2, 3, 4, 5, 6, 7, 8, negative 8 unit red tiles. Now, in the case 3, both integers have negative signs. For example, negative 8 minus negative 2. We represent negative 8 as 8 unit red tiles and negative 2 as 2 unit red tiles. Since they are both negative, we can just take away 2 unit negative tiles. We take away these 2 unit red tiles. So we take away these 2 negative unit red tiles. So we are now left with 1, 2, 3, 4, 5, 6, 6 negative unit red tiles. Now try it with yourself to test your understanding. First, 10 minus 6. Second, 5 minus 7. 3, negative 4 minus 8. And lastly, negative 15 minus negative 3. I believe that you have learned well the concept of subtraction using the algebra tiles in this lesson. Now, we will proceed to another topic, which is multiplication of integers.
Multiplication of integers is said to be as a repeated addition. In here, the order in which you multiply does not matter. For example, 9 times 4 will just only be equal to 4 times 9. So this time, we are now to take an example to illustrate the concept of multiplication of integers using an algebra tiles. From this illustration, we have positive negative n times positive negative n. If we see negative on the first factor, it means that we take the opposite of the second factor. And for the second factor, it means that there are n times either positive or negative in a group. For example, 3 times 6. So we just like what I have said a while ago, that multiplication is just a repeated addition. In here, there are 3 groups of tiles, of positive tiles. In each group, there are 6 positive tiles. So the illustration is here. From this illustration, we are now to add them all. And 6 plus 6 plus 6 is equal to 18 units of positive times. We have 5 times negative 4. So we have to add up 4 and we are to add 5 groups of negative 4 times. So as to illustrate them, we have here summing them up together. We are to get we are to get 20 units of tiles, which is equal to negative 20. This time we have negative 7 times 2. So we have to add 7 groups of 2 positive yellow tiles. So adding them up together, we have 14 yellow tiles. But then the negative sign, we have the negative sign here, which means we have to take the opposite of 14 yellow tiles. So for the final answer, we have 14, negative 14. For the third example, we have negative 2 multiplied to negative 6. And here we have two groups of 6 negative times. So for the illustration, we have here negative 6 plus negative 6. Summing them up together, we have negative 12. Again, we have the negative sign here. We are to take again the opposite of the final answer. So which is equal to positive 12.
We will now proceed on the division of integers. Division of integers is the inverse operation of multiplication. Like multiplication, division relies on the concept of a counter. Divisor serves as counter since it indicates the number of rows to create. Let's take an example. Case 1, when the divisor is positive. If the divisor is positive, then this indicates the number of rows to be performed on the dividend. Example number 1, 12 divided by 3. 3 is the divisor, so this means that we will group the 12 unit tiles into 3 groups. So we will group now the 12 yellow unit tiles into 3 groups. So 12 divided by 3 is equal to 4. Example number 2, negative 8 divided by 4. 4 is the divisor, so we will group negative 8 into 4 rows. So there are 2 unit red tiles in every 4 rows. So negative 8 divided by 4 is equal to negative 2. Case 2, when the divisor is negative. If the divisor is negative, then we will take the opposite of. Example 16 divided by negative 4. We represent this in algebra tiles as 16 unit yellow tiles. Since the divisor is negative, then this means that we will get the opposite of 16. So the opposite of 16 yellow unit tiles is 16 unit red tiles. As what we can see, there are 4 unit tiles in each 4 rows. So 16 divided by negative 4 is equal to negative 4. Example number 2, negative 15 divided by negative 3. Negative 3 is the divisor. So we will group negative 15 into 3 groups. But as you can see, negative is the sign of the divisor. So we will take the opposite of negative 15. Negative 15, the opposite of negative 15 is 15. So the 15 unit red tiles will be will be changed or transformed into 15 unit yellow tiles. This is now the opposite of negative 15. So we will now divide negative 15 into 3 rows. As you can see, there are 5 units yellow tiles in each row. So negative 15 divided by negative 3 is equal to positive 5. Now try with yourself. Number 1, 9 divided by 3. Number 2, negative 18 divided by 6. Number 3, 25 divided by negative 5. Number 4, negative 56 divided by negative 8.
Let's have a short break. Take a deep breath. Inhale and exhale. Okay, I know that you're already good in performing the different operation of integers. So let us now proceed on our new topic. This is solving equation. Algebra tiles can be used to explain and justify the equation solving process. The development of the equation solving model is based on two ideas. Variables can be isolated by using zero pairs. Equations are unchanged if equivalent amounts are added to each side.
Let's have a recall on the different representation of colors of integers which we will be using in solving equation. So, yellow small square is positive 1 unit and red for negative 1 unit. This green rectangle represents positive x, while this orange rectangle represents negative x. Let's take an example. So from the equation x plus 3 equals 5, we are asked to find the value of x using this representation. To get the value of x, we will take away 3 from the left side as well as to the right side and then apply the concept of zero pairs. So we will cancel out the zero pairs. So as you can see, what is left is equal to x was left was 2 plus 1.
As we can see, the value of x is equal to 2.
As we can see, the value of x is equal to 2.
Wait lang.
Another example, negative x minus 5 is equal to negative 2. We represent this equation in an algebra tiles as like this. So by the concept of zero pair, we are to add 5 unit positive tiles from the left as well as to the right side.
With this, by this we concept of zero pairs.
So with this, we can now cancel out the zero pairs. So we are left with negative x equals 3. But then the value of x is negative, so we will take the opposite of x and the opposite of positive tiles. So it will become, so this is the opposite, x is equal to negative 3. This is now the solution to that equation.
This is what algebra tiles is all about. Algebra tiles are really helpful for us as major teachers. This will serve as a guide for us to discuss or deliver our lessons in a more creative way. As we have said in the first place, algebra tiles are not that too expensive, so it's not that hard for us to produce this kind of manipulative. The more resourceful and productive you are, the more your students will understand its concepts. This is an effective strategy that can help your students to become more creative.
And we hope you learned something from our discussion. Again, I am Teacher Wendy.
I'm Teacher Krisha. And I'm Teacher Gina.
And I'm Teacher Carly.
Maging matalino at mapagmatya para matuto hanggang sa muli dito lang sa